Hello everyone. Today we're going to be going through merge two sorted lists, which is LeetCode problem 21. So if we look at the problem, it's saying merge two sorted linked lists and return it as a sorted list. The list should be made by splicing together the nodes of the first two lists. So what is a linked list? Basically, it's a list that contains pointers to the next item, or the next node in the list. So if you look at the first node, it has a data point, A, and then a next point that points to the next item in the list. It goes all the way down the line until you get to the last item, which doesn't have a next value, which signifies the end of the list. Okay. In example 1 here, we have two linked lists, 1, 2, 4, and 1, 3, 4, and it just wants them in order. Merge the two lists, put them in order. Example 2, we have an empty list. We have two empty lists, and so the output is an empty list. In the third example, an empty list and 0, so the output is just 0. And over here, LeetCode gives us the definition of a singly linked list. So it has an int val, it has a list node of next, and then it has three constructors. The first one doesn't take anything, so this will be used to instantiate the list node. This one has the value, and then the last one has the value and the pointer to the next value. And so that's what we'll use when we build it in JavaScript, or in IntelliJ. All right. So let's talk about the syntax for linked lists. So let's say we have a list1 equal 1, 2, 3. So list1 val equals 1, and val is coming from that list node syntax that LeetCode gave us. So list1 next is going to be 2, and then list1 next is going to be 3. So this is a syntax we're going to use for linked lists. And then, as well as solving these problems, I also like to teach new concepts. So to do this, we're going to use recursion. Now, what is recursion? Basically a method that calls itself. And my favorite line in the Austin Powers movies is, "Baby, I'd like to introduce myself to myself." A great example of a recursion method is factorials. So let's say we have 5 factorial. A factorial is basically 5 times 4 times 3 times 2 times 1. And this is the classic example for recursion. So we pass in 5, and then we have to handle the last value, which is 1. So if n is 1, we return 1. Else, we return 5 times the factorial, and then 5 minus 1, so 4. And then keep going through this. So the next time through, it's going to be factorial 4 times factorial 4 minus 1, 3, blah, blah, all the way down to the end. And then it creates instances of all these factorial methods, and then it'll run them at the end. All right. So let's pseudocode this. We have two lists, list node 1 and list node 2. So if list 1 is empty, we're going to return list 2. If list 2 is empty, we're going to return list 1. And once a list is empty, then it signifies that, okay, we finished going through the merge two lists. Now we need to basically finish off the remainder of the solution. So if list 1's current value is less than list 2's current value, then we're going to call merge two lists again after incrementing list 1's value. So this is where the recursion comes in. And then we're going to return list 1. Else, we're going to call merge two lists again after incrementing list 2's value. And then we'll return list 2. And we'll end the if statement and end the method. All right, so public list node merge two lists. So if this is basically, we're actually coding it instead of the pseudocode. If list 1 is null, return list 2. There's nothing in list 1, so we return the other list. Same thing with list 2, returning list 1. So if list 1 val is less than list 2 val, we're going to basically call the next, get the next value out of list and pass list 2. And call merge 2 lists again. We'll assign this to list 1 next. And then we'll return list 1. Because list 1 is the list that changes, so we always return the list that changes. Else, so this is the case where list 2 is less than list 1. So list 2 next equals merge 2 lists, and we're going to pass list 1 and then list 2 next. And then we'll return list 2. And that's pretty much the method. Now, this might look super confusing, but hopefully when we debug it, which we're going to do right now, this will clear things up. Okay, so let's go into IntelliJ. So if we look here, let's go back to the problem. Whoops, let's go back to, okay, so I took this method and basically put it in to IntelliJ. And I just put the constructors that we needed. I didn't put that last one there because we never use it. And then I create 2 list nodes to run through the code. So what we need to return to LeetCode is this merge 2 lists. But in order to debug it, I have to do all this setup. All right, so let's create the first list. So list node 1 equals new list node. So it's going to go up to the class list node and call the default constructor. Now we're going to add the value 1, so that's going to call this constructor. And same thing with 2 and 4. So if we look down here, list 1, it has the value 1, but the next node here has the value 2. Oops, I didn't go through 4 yet. Okay, and then the next value has the value 4. And see how the next here is null, so it's the end of the list. Now let's go through list 2 and just do the same thing here to create this list. And you see list 2, no surprise here, 1, 3, and 4, and then the null value for the last. All right, so I'm going to close these down, and so we're going to merge 2 lists, calling list 1, which is going to call the value, basically the first node. So if list 1 is null, which it isn't, list 2 is null, list 1 value is not less than list 2 value, so we're going to call merge 2 lists, passing in list 1, which is 1, and list 2 next. So if we look at list 2, it's got value 1, and the next value is 3, so it's going to pass in the 3. And look down here what it did. It created another instance of merge 2 lists, and we have the 1 and the 3 that we passed in as well. So if we go back to the first one, this is the first time we ran it, and it's 1, 1. You can see it remembers where we called it from. So if you look here, the first one there, that's the only one we have currently. Oh, we got this one. So we go down here, and see this merge 2 list is called, this is in the main program, this is what's going to be returned. Anyway, so we'll just keep going here. Now list 1 is less than list 2, so we have 1 and 3. So now we're going to do list 1 next. So we go down here to list 1, the next value is 2. So we're going to pass in 2 and 3, and it created another instance. We're basically just going to go through this until we get till we come across a list that's null. And again, 2 and 3, so we're going to increment list 1. Now we have list 2 next. So yeah, list 1 is, so one thing I want to show is if you look at list 1, it's only got the value 4. So when we do list 1 or list 2 next, it's actually removing the value out of list 1 and 2. So that's how you end up with a null list, actually. If it didn't remove the values, the list would never be null. All right, so now we have one more. Okay, so now if you look at list 2, it's null, and list 1 has the value 4. So now we're going to iterate through. We've got all these instances of merge 2 lists created. We needed to activate these or run these to complete the problem. So let's go through All right, so list 2-1, return list 1. So list 1 is going to be returned, and now if you look at list 2, it has a value 4, which is the value in list 1. So now, and then it went away. We don't have that instance 6 there anymore. So basically just keep going through and activating these. So list 2 next is from this merge 2 lists, and see how it's adding the numbers back in. So now list 2 is 3, 4, 4. List 1 next, merge 2 lists, return list 1. So now list 1 has 1, 2, 3, 4. List 1 next, return list 1. Okay, so now we're down to the last result. And that actually came from this call here, so list 2. So what we returned in the final instance of merge 2 lists was list 2. So if you look at list 2 over here, you have 1, 1, 2, 3, 4, and 4. And that is actually the same series that's in result. 1, 1, 2, 3, 4, and 4. So we successfully merged the 2 lists and returned the final result in order. All right, so let's run this in LeetCode. Suspense is killing me. Accepted. Submit it. Let's see what we got here. Look at that. Faster than 100%. And the memory usage is about it's about the middle of the road, 47%. All right, so let's finish out here with, whoops. I don't care about that. All right, so let's go through the time and space complexity. So again, time complexity, measure the time it takes. As you increase list 1 and list 2, it increases the time. Pretty straightforward, linear complexity. And space complexity is the same thing. As you increase list 1 and list 2, the values in there, it just uses more space. All right, hopefully this is helpful. I try to introduce recursion in this. It's a really important concept, and it's a basic concept in programming, and we'll probably, it's a great interviewing question, is code this using recursion. So again, good luck in your interviews. Thanks for watching, and we'll see you next time.